All right, so I'm just going to go through a couple of the problems on quiz 5.1 through 5.2 and work some stuff out for you guys. So a function is, and this would normally be a blank, so a function is blank, a discontinuity whole or vertical asymptote will occur. So remember, we're going to get a discontinuity or a whole vertical asymptote when we are dividing by zero. And a function's y-intercept can be determined by, if we're finding the y-intercept, all of our x's have to be zero. So a function's y-intercept can be determined by plugging zero in for all of the x's. And a function's x-intercept can be determined by, if we're finding our x-intercept, then our y value has to be equal to zero. And a rational function has a horizontal asymptote of y equals zero. So we're talking about the degree of the numerator and the degree of the denominator. And so the denominator has to have a higher degree. And so we can think about an example of this would be like y equals, whoops, let me erase that. An example of this could be y equals x divided by x squared. So this would reduce to 1 over x, and it doesn't matter how big or how small x is, it's never going to be equal to 0. It's going to go to 0. And a rational asymptote, or a rational function, the last one, has a slant asymptote when the numerator, the stuff on top, has a higher exponent. So we can think about this as y equals x squared over x, and that would just simplify to y equals x, which would give us that y equals x asymptote. Okay, problem number 2. So go through a few of these problems. It says, given the function f of x is equal to this, identify the following. We want our y-intercept, our x-intercept, horizontal asymptote, vertical asymptote, and wholes. And the first thing that we want to do all the time is we want to factor these things. So I'll just factor this right here. And we know that f of x, I'll factor a 3 out on the top. So factor out a 3. And so that's going to leave us with x squared plus 3x plus 2. And so that's going to factor as x plus 2 times x plus 1. And the bottom is going to factor as, we're looking for two numbers that multiply to -2 and add up to 1. So that's going to be x plus 2 times x minus 1. And so let me highlight this. So this, our x plus 2 over x plus 2, anytime we have a factor in the numerator and a factor in the denominator that's identical, that's what gives us the whole. So we know that the x coordinate of our whole, we take that factor, and we know that we set it equal to 0. X plus 2 is equal to 0. And so the x coordinate of the whole is x equals -2. I'm just going to fill this in. And so our simplified function up here, what this reduces to, it reduces to 3 times x plus 1 over x minus 1. And notice we still need to find the y coordinate of our whole. So we're going to take this x value of -2. We're going to plug this in for these two x values. And so we're just evaluating what's left, f at -2. So it's going to be 3 times -2 plus 1 over -2 minus 1. And so -2 plus 1 is -3. I'm sorry, -2 plus 1 is -1. -1 times 3 is -3. And -1, or -2 minus 1 is -2. So f of -2 is going to reduce to +1. And so pretty straightforward, not too bad. I'm just going to copy my function over here, get a little better organized. 3 times x plus 1 divided by x minus 1. So we need to find a bunch of stuff. And I guess we can start with our vertical asymptote. Remember, we're going to take whatever's on the bottom and set that equal to 0. So to find our vertical asymptote, we set what's ever on the bottom equal to 0 and solve. And so we have a vertical asymptote of x equals 1. To find our horizontal asymptote, that's our y value, right? We take, we're looking at the degree of the numerator and the degree of the denominator. And since the degree on the top and the degree on bottom is the same, it's the ratio of the leading coefficients. And we would have to distribute this 3. So this would be 3x plus 3 over x minus 1. And it's degree 1 on the top and the bottom. And so the ratio of our leading coefficients would just be 3 over 1, which is 3. Done. If we're looking for our y-intercept, they already tell us that our x values are going to be 0. So our y value would be 3 times 0 plus 1 over 0 minus 1. So this would be 3 over negative 1, which would just be negative 3. And to find our x-intercept, we know that our y value is going to be 0. So we're going to let 0 equal 3 times x plus 1 over x minus 1. And we're solving for x. So we know we've got to clear our fractions. We're going to multiply through by x minus 1. And so we multiply this side by x minus 1. And this side by x minus 1. And so 0 times x minus 1 goes away. And x minus 1 divided by x minus 1 goes away. And we're left with 0 equals 3 times x plus 1. Divide both sides by 3. And you could distribute the 3 too. I just choose to divide it out. 0 divided by 3 is 0. And 3 divided by 3 is 1. We're left with x plus 1. So x equals negative 1. And that is the x coordinate of my intercept. Hopefully this is okay for you guys. Change my scale here a little bit, zoom out so we can kind of see everything. And this is a problem I like. So we've got this function. Determine the values of a, b, c, and d so that this function, f of x equals this mess, correctly model the graph where a, b, c, and d, they're all whole numbers. The easiest thing for me to start with, I think, is probably the whole. You can start wherever you want, but that's just kind of what I think is going to be easiest to work some stuff out here. So that's negative 1, negative 2, negative 3, negative 4. It's terrible. 1, 2, 3, and 4. So if I'm looking at the whole, I notice that the x coordinate of my whole is negative 3. So the x coordinate equals negative 3. And remember, if we have a whole, then this has to be, we have to have a factor to go with this on the bottom. And so the whole, we would add 3 to both sides. X plus 3 is equal to 0. Notice I've got an x plus 3 factor on the bottom already. So I'm just going to kind of rewrite this. We know we've got f of x is equal to, I want to put this in a different order. So I'm going to start with my whole on the bottom, x plus 3. Okay, so I got my whole, and I know I have to have that same factor on the top, that x plus 3. So we need to take a look at these factors on the top and figure out which one of these factors we're going to use. Okay, so it can't be the x plus 1, and it can't be x minus b because we have a positive 3. So my a value must equal 3. And from there, we can just kind of start picking things out and figure out what we want. I notice, see if I can change color here. I notice that I've got what appears to be a vertical asymptote at -2 and a vertical asymptote at +1. And so we know that to find those vertical asymptotes, we're looking at this x plus c and this x minus d. And so talking about our VA, we have a vertical asymptote equals -2 and a vertical asymptote equals 1. So to turn those into factors, we would just add -2 to both sides, and we get x plus 2 is equal to 0, and we would subtract 1 from both sides. We get x minus 1 equals 0. So looking at, we've already used x plus 3 is good. So our c value has to go here. So c has to be 2. And for our other factor, x minus 1, that has to be our d value. So d has to be 1. And now we're just left with this x plus a and this x minus b on top. And remember, if we set this thing equal to 0, this x plus a, this x minus b, and this x plus 1, those are going to give us x-intercepts. So we have an x-intercept here. And now the x plus a, remember that reduced with my whole because that's x plus a is really x plus 3. So that gave me my whole, and those factors are going to reduce. Let's fill in some other factors down here. We've got x plus 2 and x minus 1. So what we need to figure out on top is our x minus b and our x plus 1, and we're just looking at our x-intercepts. So here we have an x-intercept, x equals -1. We'll do it right here. So we know that this factor, if we turn this into a factor, it should be x plus 1 equals 0. Our other factor, or our other x-intercept, is at 4. So x equals 4. Solving, we subtract 4 from both sides, equals 0. So let's take a look at what we've got left. We have x minus b. That has to be our x minus 4. So b is 4, and we're good. And that's it. And we already had our x plus 1 factor right there, so I don't have to do anything with that. It was just extra work. Okay. So select the correct equation for the following graph. I kind of want to talk about a couple of things. So we know that this has a slant asymptote. And we know that if we have a slant asymptote, the degree on top has to be bigger than the degree on bottom. So let's take a look at can we get rid of any of this stuff? Here we have degree 1 on top and degree 2 on bottom. So it can't be this one because this is going to have a horizontal asymptote of y equals 0. And again, our second problem, it's degree 1 on top, and if we multiply the bottom out, it's degree 2 on the bottom. So again, it cannot be this one. So we're left with this and this. And to figure out like what's going on, I'm going to use my x-intercepts up here. And that's really what we need to know. So I know that I have an x-intercept at -1 and +2. So for my x-intercepts, and these, we're going to turn them into factors, and these would be on the top. So we have x equals -1 and x equals 2. We solve, and we get x plus 1 times x minus 2. And so these are my x-intercepts, and we know we have x plus 1, x minus 2 over 2 times x plus 3. So we know that this has to be the correct answer.